We're going to run through the 1.2 problems that you did yesterday at home, kind of give a little more explanation and review some of the 1-2 concepts as we go here. So with domain, I'm not going to graph these. I'm going to go through kind of my steps and say, all right, first and foremost, do I have a fraction? Well, I have 2 in this case. And so remember, in fractions, the bottom cannot equal 0, which means I can't use 0 and I can't use 3. And so my domain, and everything else works. So I'm going to go negative infinity to 0, in union with 0 to 3, in union with 3 to infinity. Okay. Now with your square root, the process was to take the inside, the guts, the stuff underneath, whatever, that all has to be greater than or equal to 0. Because we can square root a negative and get a complex number, but we're not working with complex if we're talking on a graph x and y, if there's no imaginary numbers on there. So this is what I'm solving. Now there's a little extra factoring in here because I have x to the 4th, but I have an x squared as well. So I can factor out x squared, and now I have x squared minus 16 is greater than or equal to 0. Well, I actually can still factor because this is your difference of perfect squares. So I have x minus 4 and x plus 4, and then is that greater than or equal to 0? Now from here, you know, like in P5, my zeros are 0 for that factor, 4 for the next one, and then negative 4. But I can't use that greater than symbol anymore. I'm not greater than all of these values. I now have to switch to some type of evaluating with, in this case, a sign chart to figure out where am I actually above 0. This one, the sketch thing, doesn't work. It's not a quadratic anymore. You're not sure where things are going. And this is where we talked about you have to be able to do a sign chart, and especially going forward, not sketching. Sketching is not going to work every time. Okay, so I go here and I pick a number less than negative 4, so we'll use negative 5. So if I put negative 5 and I square it, that would be positive. If I put negative 5 and I subtract 4, that's a negative number. If I take negative 5 and I add 4, that also is a negative number. Those would multiply to a positive number. So 2 negatives go positive, and then you already had a positive. All right, so let's use negative 1 is in my next interval. So negative 1 squared is positive. Negative 1 minus 4 is negative. Negative 1 plus 4 would be positive. Those 3 things would multiply to some type of negative number. All right, let's try 1. So 1 squared is positive, 1 minus 4 is negative, 1 plus 4 would be a positive. So those also give you a negative value. And then if I try 5, 5 squared is positive, 5 minus 4 is positive, 5 plus 4 positive. So this thing is positive. So this is what your sign chart. And remember, I warned you, not everything will alternate. Here is one where you do not always alternate. So now I go back here. These are the values I want. Greater than 0. Greater than 0 are positives. There is one extra value that will work here, and this is a very hard example over that way. Your 0 will make this true, your value of 0 down here, because that is where you will be greater than or equal to 0. So if you had your domain, you know, negative infinity to negative 4 bracket in union with, I'm going to skip a little room here, 4 to infinity, like that, you're fine. That is a fantastic, you are on the right track. You technically can also use 0. And so we're going to do that by just kind of putting 0 in its own little bracket. This will not be on a test. This will not be in your homework. It could have been in your homework, but this is like the challenge. The other parts we could have got from factoring in the sign chart, but oftentimes we forget that 0. So if you forgot it, no worries. It's very, very common. All right, next question. We have this h function. Tell whether or not it has a point of discontinuity at x equals 0. If there is discontinuity, tell me if it's removable or not removable. So I go look at it, and I'm like, all right, I got a fraction. I have an x in the denominator. I have to have some version of discontinuous because I would get a divide by 0, in this case, at 0. Now, whether it's removable or not, remember that we have to do some algebra and see if we can factor and cancel. So I'm going to take my numerator. I notice I can factor x out. So x squared plus 1 all over x. I can now cancel those factors. So this thing would have removable. Okay, you need to show this process. So if it is like show this is removable, like show what you are doing. If you are like, I'm just going to graph this thing, and you take your calculator and you graph this, your picture is going to look like that. And it is going to mislead you, and you're going to say there's no discontinuity. It's continuous the whole time. It is not continuous. There is a hole there. The only way you are going to see that on your calculator is if you look at the table and you see the word error at next to the 0 part. It will say error. But otherwise, you've got to do this algebra to see that that's discontinuous. All right, the next one, I am missing the picture here. I'm going to sketch mine in quick here. Something to that effect. And it wants to know, for each of the labeled points, tell me if it's a min, max, or neither. So this is 1, 2, 3, 3. My drawing is just as bad on your paper, sorry. And 5, 7. All right, so let's go through the first one. So 1, 2, that would be, to the best of my drawing, is meant to be a local min. 3, 3. Now, there's a part of you that might want to be like, okay, well, maybe it's kind of a minimum. But when we talked about local mins and max, we said you had to change directions, change increasing to decreasing. You like slow down here, but you don't go back down. So this is your neither. It's just like a pause, and then you keep going up. And then 5, 7 would be your maximum. Okay, second part then asks for increasing and decreasing. So just like I did in notes, I'm going to put pluses and minuses on here so I can see it. Then I'll go write out what it is. So this piece is going down, so I'm decreasing. You can put a D if that's more helpful. Now I would be going up this whole time, even though, yes, there's the pause that right there, but you didn't switch directions, so you're still going up. And then this part's going down. So I would be increasing. Now I need to be careful. I got a 1, a 2, a 3, a 5, a 7. Which of those numbers do I use? Well, you remember we talked about your answers should be intervals of x's for increasing, decreasing. So I start increasing here, which has an x value of 1. I stop increasing up here, which has an x value of 5. I don't want brackets on those. Your book will put brackets because you have dots in those spots. But you're no longer increasing or decreasing in my calculus definition, so just leave them. All right, this piece then, I'm going decreasing now. So this whole piece would be decreasing, and in terms of x's, I'm still going left. So it would be negative infinity to 1, and then I'm decreasing here on, so that would be 5 to infinity. Then we want to do a little bit with our grapher. So hopefully you got that in your grapher. It's a sketch similar. Whoop. Hang on. There we go. Similar to that. And I want you, it asks you to find local max and mins. So you would have so reading directions, it says find all local max and minima and the values of x where they occur. So you would have a maximum of y equals 4.08 at x equals a negative 1.15. That's this point. And you would have a minimum value of negative y equals negative 2.08 at x equals 1.15. That is, let me clean this up. Clean that part up so you can actually read it. Y equals negative 2.08. If you need grapher help, please let me know. I'm more than happy to do it, please. All right, odd, even, neither. And I'm gonna, I think you can type these in on your calculator. I'm gonna kind of focus more on the confirm algebraic part on here. So algebraically, what we are looking for, we are looking to compare f of x and f of negative x, the opposite x values. So in this case, the f is g. I already have g of x, so now I want to know what is g of negative x. So even if I know it off the top of my head, I have to show my plugging in because this is an algebraic proof. Now if I have negative x and I'm cubing it, I have 3 negative values multiplying, which would just give me a negative x cubed. Now I compare these two. These things are opposite. So x cubed is an odd. function. Okay, let's do with one a little more complicated. So my f of negative x, I plug it in parentheses everywhere. Negative x squared plus 3. And we just figured out that's just negative x cubed. Negative x squared, so squaring any number makes it positive. So this would say plus 0.04. This would now be x squared, and then plus 3. When I start comparing parts, those parts are opposite. These parts are the same. So this is that neither situation because it's not all opposite or all the same to be even. So that is your neither. All right, on the back here, all my vertical and all my horizontal asymptotes. So let's do vertical asymptotes for both of these to make life easier. So vertical asymptotes are where you've got x values that you cannot use, which would be where your denominator equals 0 or bottom equals 0. So my first one is at x equals 0. As a reminder from our class talk, you cannot write vertical asymptote 0. I will 100% mark that wrong. 0 is not a line. Vertical asymptotes are lines. You need the x equals. So start doing whatever you got to do to remember that and put it on your note sheet, whatever. All right, now this one, I'm going to set my denominator equal to 0 and solve. So I have x squared equals negative 1. I square root, and I do the, wait a second, I'm getting plus or minus I. Okay, well, I is not on a graph of anything, so there are none. Not every function has a vertical asymptote. That is a fraction. It just so happens this one always gives you positive. It can never spit out 0 because you're always getting, you know, the smallest number you can get here is 0, and then you add 1 to it, so it's always positive. All right, your horizontal asymptotes, if you look at your notes, fell into one of 3 situations where you compared your powers. So in this first one, you have powers of 1 in the top and bottom. So that's the first case, whereas the y equals your leading coefficient over your leading coefficient, which are both 1 in this case. So it's y equals 1. This one, second one, is the bottom power is bigger. And when the bottom power is bigger, your horizontal asymptote is 0. All right, your last problem wants you to graph this x cubed with the x there. It's something like this. My sketch is pretty rough, but I'm just looking for, is it bounded above, below, bounded on its domain? Really, there could be a fourth option here. I'll put unbound, because it could be none of those, and this just so happens to be the one that is unbound, or neither, or to whatever, however you want to describe that. So it's not bounded above. So remember, above would mean like I have a line up here and it doesn't cross it. Well, I cross it. Down below, I'm definitely not bounded because I keep going. And then bounded is both of those. So this is that unbounded.